Okay, thanks for coming back. We're just finishing up our notes from section 5.3. Here's our last example. So remember, we're going to graph this rational function. Remember, there's three characteristics we have to look for. We have to look for the zeros, the vertical asymptotes, and the horizontal asymptotes. And we learned that for the zeros, we're going to set the numerator equal to 0. So here's our numerator, 2x squared. We're going to set that equal to 0 and solve for x. We're going to divide by 2. So we get x squared equals 0. We know that the root of 0 is just 0. So that's where our value of 0 is. It's at x equals 0. So that's a point. This, remember, a 0 means the x-intercept, which is a point at that value of x on the x-axis. Okay, so we just did the 0. Let's do our vertical asymptote now. So remember, the vertical asymptote, we take the denominator function and we set it equal to 0. So we're going to take this denominator, x squared minus 9, and set it equal to 0. Let's solve for x by adding the 9 over to the other side. Take the square root. Remember, we always take plus or minus. And we get x equals plus or minus the root of 9, which is 3. So our vertical asymptotes, there are two. They're at x equals 3 and x equals negative 3. And we're going to put some vertical asymptote lines to remind us where they are, because we know the graph will never hit anywhere on that line of x equals 3 and negative 3. Lastly, our horizontal asymptote, now we're going to compare the degrees for both of these. So we've got y equals 2x squared over x squared minus 9. So remember, these are our degrees. So 2 and 2, so m is 2 and so is n. These are equal to each other. So remember, when m equals n, then the horizontal asymptote is y equals a over b. A over b is, we're talking about the coefficients of the functions in front of x, which is, or the coefficients in front of x, which are, this is a and this is b. So we say the horizontal asymptote is y equals a, which is 2, over 1, which is 1. So that's our line at y equals 2. So here's our value at y equals 2. And we have a horizontal asymptote here. So these are kind of the areas that we could see a function at. So we've set up the graph so we know what this will look like. So now that we've gotten all three of those done, now we're going to find our x and y coordinates. So we're going to go to the left, the right of each vertical asymptote and pick two values for x. So here's two values to the left of negative 3. You can pick any two values to the right of negative 3. And what's cool about this, it's going to be inside the region in here. So let's just pick some easy values. Let's pick 0. Well, actually, we already know 0 because that's our point right there. So let's pick negative 1 and 1. We already picked negative 4 and negative 5. And then we're going to need to pick something on the right side of this vertical asymptote. So let's pick 4 and 5. All right, so let's plug this in to our original equation, which I rewrote right here. So we know y equals 2x squared over x squared minus 9. So that means 2 times negative 1 squared all over negative 1 squared minus 9. That becomes 2 times 1 over 1 minus 9, which is 2 over negative 8, which is negative 1/4. And if I want to put it in a decimal, it's 0.25. Okay, I'm going to need to change the size of my pen. I'm going to go zoom in a little bit here. And then this is going to be 2 times 1 squared all over 1 squared minus 9, which is 2 over negative 8, which is negative 1/4 again, which is 0.25. Okay, let's do the next one. And at -4, we go 2 times -4 squared all over -4 squared minus 9. This becomes 2 times 16 all over 16 minus 9, which is going to be 32 over, what is this, 7, which is approximately, if I put that in my calculator, 4.6. Okay? So we've got 2 times -5 squared all over -5 squared minus 9. 2 times 25 is -5 squared. 25 minus 9. That gives me 50 over 16. And if I put that on my calculator again, we get 3.2, and I'm rounding that a little bit because we just need to be able to graph it. Plug this back in again. We've got 2 times 4 squared all over 4 squared minus 9. We get 2 times 16, because 4 squared is 16, and 16 minus 9 again. That's 32 over 7, which is another 4.6 as before. And then 2 times 5 squared all over 5 squared minus 9. That's 50 all over 16, which is another 3.2. So we're going to take all that information, I know that was a lot, and we're going to graph these points, -1, comma 0.25, 1, comma -0.25, -4, comma 4.6, -5, comma 3.2, 4, comma 4.6, and 5, comma 3.2. Okay, so we're going to bring that up here at this graph, and we're just going to give it an approximate. At -1, it's at 0.25 negative, so it's about right here. At 1, we're at, again, -0.25. It looks like this. So if I were to connect those two, remember that green dot is our x-intercept, or 0, and it's going to look like this, and we're going to connect them, and they're going to follow down. And then at -4, the value is at positive 4.6. Remember, this is 1, 2, 3. Here's positive 4. So we know that dot is at -4, comma 4.6. It's right here. And at -5, it's at positive 3.2. So we're going to connect these dots and follow the asymptote. And then lastly, at positive 4, it's at 4.6. And at positive 5, it's at 3.2 again. And we're going to connect those dots and follow the asymptotes. Okay, and then here's how we would describe the domain and the range for that. So remember, the domain is all reals, but it's where the x, or the x values for the vertical asymptotes is not. So we look here and here, and we know the values that x can equal 3 or -3 are where the vertical asymptotes are at. So that's where our domain is. It can be anything, but not 3 or -3. Our range, we're going to look right here at this horizontal asymptote. We've got all reals, and y cannot equal 2. All right, that's the rest of our notes for today. What I would like you to do is take our examples and apply them to the start of your homework, which is in Google Classroom. Go ahead and spend up to 20 minutes on that, trying to work that out on your own. Look for the zeros. Remember, to find the zeros, we take the numerator, so to equal to 0. The vertical asymptotes, we take the denominator and equal it to 0. For the horizontal asymptote, we compare the powers. Okay, and then all the rest of our questions we will answer on Tuesday. Don't forget, Pi Day is Sunday, so make sure you take advantage of that extra credit. Bye.